Okay, we'll continue with the core of the background of the X-ray analysis or X-ray crystallography. Okay, so X-ray crystallography basically was developed based on the Bragg law. Okay, I believe all of you know what Bragg law, right? 2d sine theta equal to n lambda. And we have many ways to prove the Bragg law. Okay, later on I will discuss on it. How do we prove the Bragg law? The Nobel Prize in Physics 1915 was awarded jointly to Sir William Henry Bragg and William Lawrence Bragg for their service in the analysis of crystal structure by means of X-ray. So with the contribution from these two scientists, Sir William Henry Bragg and William Lawrence Bragg, we have developed the X-ray crystallography. So I will show you a 3-minute video on the crystallography. Okay. Okay.
Why water boils at 100 degrees and methane at minus 161. Why blood is red and grass is green. Why diamond is hard and wax soft. Why glaciers flow and iron gets hard when you handle it. The answers to all these problems have come from structural analysis. That's how the Nobel Prize winner Max Perutz summed up X-ray crystallography. Never heard of it? Don't worry, not many people have. Yet it's arguably one of the greatest innovations of the 20th century. 28 Nobel Prizes have been awarded to projects related to crystallography. And the very first of those is where it all began. It's now 100 years since, following early work by Max von Laue, the first structures were determined by father and son team William and Lawrence Bragg. In 1913, they fired a narrow beam of X-rays at a humble salt crystal and photographed the diffraction pattern as the crystals split the beam into many rays. Lawrence soon realized that this pattern held the clues to the atomic structure of the crystal itself. The equation he developed, Bragg's law, made it possible to work out how the spots in the diffraction pattern are related to the specific arrangement of atoms in the crystal. 2 years on, and the Braggs were awarded the Nobel Prize. Impressive stuff. Not only that, the Braggs mentored a dream team of crystallographers who went on to work out the structures of a huge range of molecules. From Kathleen Lonsdale, J.D. Bernal, Dorothy Hodgkin, to David Phillips, John Kendry, and Max Perutz. Remember him? Plus, Rosalind Franklin and others even helped map the structure of DNA, probably the most famous result of X-ray crystallography. Today, the work hasn't stopped. Crystallography remains the foremost technique for working out the atomic structures of almost anything, which is very useful for finding out why things behave the way they do. From the metallic structure of the blades of a jet turbine to the immune system fighting off viruses. Turns out, Max was right. Modern crystallographers are doing exactly the same thing as the Braggs, just at a larger scale, with more sophisticated mathematical methods and more impressive machines. Crystallography is even reaching beyond our planet. Curiosity rover is now performing X-ray diffraction analysis of the soil on Mars. But there's plenty of unfinished business back on Earth. There are still many thousands of complex molecules to look at, and a lot more questions to answer.
Okay, so I hope you have enjoyed the video just now. So the video just now has actually described what is the application of X-ray and also the development of the X-ray crystallography. All right. So let us take some easy rest. So do you know who are them? Do you know who is he? Stephen Hawking. Okay, he's a very famous scientist. Do you know who is he? Richard Feynman. Who is he? I think most of you know who is he, right? Albert Einstein. Okay, this is when he get older. This one, Isaac Newton. And this one, Galileo Galilei. Okay, so this is a very famous photo that they almost cover most of the subject of your undergrad program. Can you recognize them? Okay, we have many scientists here. Can you look at their name and see how many names that you recognize? Debye theorem. You're going to study the Debye theorem in solid state physics 1. Okay, later on, the Bragg law. This one, Carmel, Dirac, Bohr, Max Born, de Broglie, Compton, the X-ray. Okay, I think you know of them, right? Lawrence, Albert Einstein, Curie, the madams, Planck, this one, Langevin, who else? Heisenberg, Rillon Jones, remember I mentioned in the early of this course. Pauli, and then who else? Schrodinger. Okay, so like what I told you, this group of the scientists basically cover most of the subject that you study in your undergrad program. Okay, and you should recognize them lah. So they are the one who make you study all this thing lah. Okay, so these are the outstanding one like Max Born, Newborn, Einstein, Lawrence, Planck, de Broglie, Schrodinger, and Heisenberg. Right. Okay, we come back to the Bragg law. Okay, so for the Bragg law, this is what you have learned from previous, maybe from the secondary school. What you do is that you get a path difference between the two reflected ray at the 2D sine theta. So we have one incident ray and second incident ray. Then when they hit on the sample, it will be reflected. Okay, it will be reflected. Then this is an incident, this is an incident, this is a reflected, this is a reflected. Then incident 1 and 2, reflected 1 and 2. So there's a difference between the reflected 1 and 2, right? They got extra distance. So we call this